Hello students, today we will be solving few more questions of compound interest, but before starting this, there's a student called Remil Dhan. Okay, he has asked me, he or she, I don't know, I'm not sure, has asked me n minus 2 factorial. How can I write it as n minus 2 into n minus 3 factorial? Okay, we'll start with this only. Okay, so suppose 10 factorial I'm writing. Okay, 10 factorial is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? So this is 10 factorial, right? Okay, so 9 into 8 into 7 into 6 into 3 into 2 is 9 factorial. So that means 10 factorial I can write as 10 into 9 factorial, right? Okay. Suppose now n minus 2 factorial I have written. Okay, I'll just name n as, I'll give n one value. Suppose n is equal to 8. Okay, so n is equal to 8, then n minus 2 will be 6. N minus 2 will be 6. Okay, so 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, right? So I can write 5 into 4 into 3 into 2 into 1 as 5 factorial, correct? Okay, so 6 factorial I can write as 6 into 5 factorial, correct? Okay, so n is 8. Okay, n minus 2 will be 6. N minus 2 is 6, right? So here n minus 2 is 6 because n is equal to 8. N minus 2 is 8. So I mean n 8 minus 2 is 6, right? If n is equal to 8, what is n minus 3? 8 minus 3. 8 minus 3 is 5. So 6 factorial, if I can write it as 6 into 5 factorial. Same way, n minus 2 factorial, okay, will be n minus 2 into n minus 3 factorial, right? Because if n minus 2 is suppose 6, n minus 3 is 5. Okay, I hope you got it. Okay, so okay, I'll write it in other way. Okay, 6 factorial into 6 into 5 factorial, so one number less, correct? 5 is one number less. Okay, if this is n minus 2, 5 is n minus 2 minus 1, which is n minus 3, one number less. One number less, n minus 2, one number less will be n minus 2 minus 1. N minus 2 minus 1 is n minus 3. Okay, so that's why n minus 2 factorial, I can write it n minus 2 into n minus 3 factorial. Okay, because n minus 3 is 1 less than n minus 2. Okay, I hope you understood. Now let's start solving. Okay, how much will rupees 32,350 amounts to in 2 years and 3 months at 12% per annum, interest payable quarterly? Okay, 3 months means 0.25 year, correct? So 2 year 3 months means 2.25 year. Okay, because 3 months means 1 quarter, that is like 25% of a year. Okay, so 2 months, 2 year 3 month, I can write it as 2.25 year. Okay, in 1 year there are 12 months, out of that 3 months, so 3 by 12, just do 3 by 12, you will get 0.25. So 3 months means 0.25 year. Okay, so I just converted 2 years 3 months into year. 2 years 3 months means, okay, 2 years 3 months means 0.25 year. Okay, how much will rupees 32,350 amount to in 2 years and 3 months at 12% per annum interest payable quarterly? Okay, that means every year. Fine. Okay, so we can solve this in 2 ways actually. Okay, so let's solve in both the ways. Now this is I have just converted month into year. Okay, so 3 months is 3 by 12, which is 0.25 year. Okay, so the period, that means n, is equal to 2.25 year. Okay, r is 12%. 12% means 0.12. Okay, it's payable quarterly. P is given as 32,350 and you are supposed to find A, right? So formula for A is equal to P into 1 plus R upon 4, because interest is paid quarterly, 4n. Okay, so this is the formula. Payable interest is payable quarterly, that means in a year 4 times it is paid. Okay, so 4 times interest is calculated, so divide r by 4 and multiply n by 4. Okay, so yeah, so this is the formula. P is 32,350. 1 plus r is 0.12, divide by 4 raised to 4 into 2.25. Okay, so 32,350, so 0.12 divided by 4 plus 1. 0.12 divided by 4 is 0.03. Okay, plus 1 will be 1.03. So 1.03 raised to 4 into 2.5. 4 into 2.25, right? 2.25. It comes to 9. Okay, so this raised to 9. Let's calculate 1.03 raised to 9. 1.03 raised to 9 into and is equal to 8 times. 2, 3, 4, 5, 6, 7, 8, 9. It comes to 1.30477. So I'll write 1.3048. 32350 into 1.3048. 1.3048. Let's multiply this. 1.3048 into 32350. It comes to 42,210.28. 42,210.28. Okay, so this way you can solve this problem. Okay, I'll tell you other way, and I will prefer if you all do that method. Okay, so first in one bracket you will solve for 2 years, and in other bracket you will solve for in other bracket you will solve for 3 months. Okay, so A is equal to P into 1 plus R raised to 4 upon 4n. Okay, no, not, yeah, and this n is for 2 years. Okay, into 1 plus kr. Okay, you will not do divide by 4, because in 3 months it is like interest is calculated only once, right? So you will not do divide by 4 in this case. Okay, because it is, this bracket is for 2 years and this bracket is for 3 months. Okay, during 2 years, okay, like every year, in 1 year you are computing interest 4 times, because interest is computed quarterly. Quarterly means after every 3 months it is computed. Now here in the second bracket, when you are calculating for 3 months, in 3 months you are computing only once. Interest is computed only once, so you will not do divide by 4. This you will not do. Okay, so let's calculate. Let's see if we get the same answer. Okay, P is 32,350. 1 plus R is 0.12, divide by 4, yeah, raised to 4 into 2, because 2 years. Okay, so 4 into 2, then 1 plus K is 3 months, 3 by 12, and R is 0.12. Okay, so let's calculate this. Okay, 32350 into, you have calculated this bracket already, it comes to 1.03, correct? 4 into 2 is 8. Okay, let's calculate this. 3 into 0.12 divide by 12, it will come 3.01, I think. Let's calculate. No, I'm not sure, sorry. 3 into 0.12 divide by 12, 0.03. okay, yeah, this comes to 1.03. okay, so when you compute this into this is 1.03 raised to 9, correct? We got the, see, we are in the same step. Okay, this is 32,350, 1.03 raised to 8 into 1.03, so it will be 1.03 raised to 9, correct? And this is the same answer we are going to get, correct? So yeah, you can either use this formula, okay, or you can use this formula. Fine. Okay, when you are using this formula, you have to make sure this doesn't come in point or something. If this comes in point and all, so you cannot use this formula. Okay, suppose the answer, when you multiply, suppose the answer is 9.5, okay, then you won't be able to calculate, right? Okay, so in that case you have to use this formula. So in the exam it is better if you always use this formula. Okay, it will always give you a right answer. Suppose interest is calculated monthly. Okay, so if interest is calculated monthly and the period is 2 years 3 months, in that case what you would have done? Here you would have done divide by 12 multiplied by 12. So here it will be 12 and 12, correct? I'll use different color. Okay, here it will be 12 12. Okay, 2 years 3 months, and this k is for 3 months, right? So 3 by 12, instead of k you will write 3 by 12. Okay, r is whatever the rate, which is 0.12. You will do divide by, because it is 3 months, so interest is computed thrice in 3 months. So you will do divide by 3 in this case. If in the question it was interest is computed monthly. Okay, if interest is computed monthly, in a year interest is computed 12 times. So r divided by 12, n multiplied by 12. Okay, and 2 years 3 months, so this bracket is for 3 months, right? Okay, so for 3 months, if it is 3 months, interest is computed thrice. So you will do r divided by 3. Okay, let's come to the next question. Find rate percent per annum if rupees 2 lakh amounts to rupees 2 lakh 31,525 in 1.5 years, interest being compounded quarterly. Okay, the formula to find r, because find rate is asked, so you have to compute r. So r is equal to anti-log log a minus log p upon n minus 1. This is the formula for r. But because interest is being compounded quarterly, so you will do that means in a year 4 times interest is computed. So r divided by 4 and n multiplied by 4. R divided by 4 and n multiplied by 4. So now this is the formula. Okay, so let us substitute. R divided by 4 is equal to anti-log log a. A is 2 lakhs minus log p. So log 2,31,525 divided by 4n. So 4 into n is 1.5 minus 1. Okay, substitution done. Let's start solving. So r divided by 4 is equal to anti-log. Okay, first we'll solve this bracket. Okay, so log 2 lakh. In 2 lakh there are 6 digits. So in 2 lakh there are 6 digits. So 6 minus 1 is 5, right? So let's find log 2 lakh and log 2,31,525. Okay, so in log there are 6 digits. So 6 minus 1 is 5. So it is 5 point something. Okay, so the column 20, row row 20, column 0 and mean difference 0. Let's see that in the log table. Okay, so column 20, row 0 is 3010. Okay, and mean difference of 0 is always 0 only, because mean difference, see, if you see mean difference, it is 1 2 3, it starts from 1 2 3. Okay, so 3010. Column 20 is 3010. Okay, just a second, I have done one small blunder. Okay, substitution. Log A is 2,31,525 and log P is 2 lakhs. Okay, so let's find for 2 lakh only. It came 3010. Mean difference is 0, so you are adding nothing. Okay, now here log 2,31,525, again there are 6 digits, 6 minus 1, so 5 point something. Column 23, row 1, mean difference 5. Okay, column 23, row 1, that is 3636. Okay, so I'll just write it 3636. 3636 and mean difference 5. So mean difference 5 for column 23 is 9. Okay, mean difference 5, column 23, mean difference 5 is 9. So add 9. Okay, so 9 plus 6, 5 4 3 6 4 5. Okay, so log is 5.3645. okay, so 5.3645 minus 5.3010 divide by 4 into 1.5. 4 into 1.5 is 6 minus 1. Okay, I will just erase this because due to lack of space. Okay, so r by 4 is equal to anti-log. Okay, we'll just solve the bracket. 5.3645 minus 5.3010 divided by 6. 5.3645 minus 5.3010, it comes to 0.0635 divided by 6. It comes to 0.01058. So 4 decimals we can keep. So 0.06. Okay, anti-log 0.0106. Okay, and then minus 1. Okay, so let's find anti-log of 0106. Okay, so you will ignore the digit before the decimal point. 0106. 0.0106. So column 0.01, row 0 and mean difference 6. This is column. sorry, this is row, this is column, okay, and 6 mean difference. Okay, so 0.01, 0.01 for anti-log table. Let's go to anti-log table. 0.01, column 0 is 1023. Okay, 1023, and mean difference 6 is 1. Okay, so 1023, okay, and mean difference 6 was 1, so you have to add, so 1024 it becomes. Okay, so anti-log 1024. Okay, so before the decimal there are no digits, 0 digit, right? So 0 digit plus 1, so it comes to 1. So after 1 digit you will put a decimal point, so 1.024. okay, I'll just erase the working note. Okay, so 1.024 and then minus 1, so it becomes 0.024. okay, therefore r divided by 4 is equal to 0.024. so r, 4 you take it to the other side, 0.024 multiplied by 4. Okay, let's see what you get. 0.024 multiplied by 4, it comes to 0.096. 0.096. So r is equal to 0.096. That means r is equal to 9.6%. Zero 0.096 means 9.6%. Okay. Okay. One more thing I would like to mention, like in the previous question. Okay. For example, the formula is, suppose A is equal to P into 1 plus R raised to N. Okay. So in the place of R, suppose R is 9%. So you can either write 0.09 or you can write 9 divided by 100. Okay. Some students, what they do, they write 0.09 divided by 100. This is wrong. R is 9%. 9% means 9 upon 100. Okay. 9 upon 100 means 0.09. Okay. You cannot write 0.09 divided by 100. Then it becomes wrong. Okay. So in place of R, you better you write 0.09 in decimal only. Divide by 100, don't write. Okay. Okay. So let's come to the next question. In what time will a sum of money double itself at 10% per annum compound interest payable half yearly? Okay. So time is asked, that means T is asked. T or N, it is one and the same thing. Okay. So here, suppose the sum of money is doubling itself. That means if P is equal to 100, A will be 200. Okay. So let P is equal to 100. Let P is equal to 100 and A is equal to 200. Okay. So R is 10%. 10% means 0.10. Okay. And interest is compounded half yearly. Okay. Interest is compounded half yearly means in a year twice interest is compounded. So you will do r divided by 2 and n multiplied by 2. Okay. So we don't know n, right? So the formula for n is, when you want to find n, the formula is log a minus log b upon log 1 plus r. This is the formula for n, right? But here interest is payable, compound interest payable half yearly. Because interest is compounded half yearly, you will do r divided by 2 and n multiplied by 2. So this is the formula. Okay. So let's start solving. 2n is equal to log 200 minus log 100 divided by log 1 plus r. R is 0.10 divided by 2. Okay. So 2n is equal to log 200 minus log 100 divided by log 0.10 divided by 2 will be 0.05 plus 1. So that will be 1.05. Okay. So let's find log for 200, 100 and log 1.05. Okay. So you have to find log 200, log 100 and log 1.05. Okay. So here before the decimal, there are 3 digits. Correct? Before the decimal there are 3 digits. So 3 minus 1, so 2 point something. Before the decimal there are 3 digits, so again there is 2 point something. Before the decimal there is only 1 digit, so 1 minus 1 is 0, so 0 point something. Okay. So now row 20 column 0. Okay. Let's see row 20 column 0. Let's go to the log table. Row 20 column 0 is 3010. Okay. So mean difference is 0. So 3010. Row 10 column 0. Let's see row 10 column 0. 0000. That means 2 only this is. Okay. And row 10 column 5. Row 10 column 5. Row 10 column 5 0212. 0212. Okay. So we have found log. Okay. So 2n is equal to 2.3010 minus 2 divided by 0.0212. So this will be 0.3010 divided by 0.0212. Okay. So let's divide this. 0.3010 divided by 0.0210. Okay, let's divide. 0.3010 divided by 0.0212. 14.198. Okay, 14.198. Okay, here it is 2n equal to 14.198. So n is equal to 14.198 divided by 2. Okay, so instead of n you can write t also. Okay, so 14.198 divided by 2, it will be 7 point something. So 14.198 divided by 2 is 7.099 year. So answer is n is equal to 7.099 year. Okay, or you can write time is equal to 7.099 years. Okay, let me explain now nominal rate of return and effective rate of return. So nominal rate of return and effective rate of return. Okay, okay, suppose I am depositing 10,000, okay, for 1 year, interest compounded quarterly, and rate of interest is 10%. So rate of interest is 10%, so nominal rate of return is 10%. Okay, so 10,000 I am depositing, so that means my P is equal to 10,000. Okay, for 1 year, so my N is equal to 1 year. R is equal to 10%, so which is 0.10. Okay, and my interest is compounded quarterly, right? So now in this case, if I want to find CI, compound interest, okay, so my formula will be CI is equal to P into 1 plus R raised to N minus P, correct? But because my interest is compounded quarterly, so I will do N into 4 and R divided by 4. Okay, so in this case my principal is 10,000. 1 plus R is 0.10 divided by 4 raised to 4 into N, like interest is compounded for N is 1 only, 1 year, so raised to 4 only, right? 4 into 1 is 4 minus P is 10,000. Okay, so let's compute this. So 10,000 into, okay, let's calculate 0.10 divided by 4 plus 1. So 0.10 divided by 4 plus 1, it comes to 1.025. okay, 1.025 raised to 4 minus 10,000. Okay, now here 10,000 into 1.025 raised to 4, let's calculate this. 1.025, okay, into, okay, raised to 4 means is equal to, you have to press 3 times, 1 2 3, it comes to 1.1038. okay, so 1.1038, right? 1.1038. okay, so now minus 10,000. Let's calculate this. Okay, 1.1038 into 10,000, okay, which is this, minus 10,000, which is 1038.12. We can just ignore that 0.12. Okay, so it comes 1138. So my interest is 1138. Okay, I mean the compound interest is 1138. So if I am depositing 10,000, I am earning 1138. Okay, when I invest 10,000 for 1 year, rate of interest is 10%, but because compounding is done quarterly, so I am earning 1138. Okay, so how much is 1138? What percentage I am earning? 1138 I am earning when I invest 10,000. So when you do into 100, actually I am earning 11.38%. Okay, so if I am earning 1138 in a year when I invest 10,000, that means my effective rate of interest is 11.38%. Okay, but you don't have to calculate like this. Okay, because you are earning, because of the compounding, okay, my rate of interest was actually 10%, but because of compounding I am earning 11.38% of my investment in a year. Okay, so this 11.38% is my effective rate of return. Okay, but you don't have to do this whole thing. Okay, instead there is a formula which is RE is equal to, E stands for effective rate of return. Okay, RE stands for effective rate of return. Okay, and R stands for rate of interest. Okay, and RE stands for effective rate of interest. Okay, so the formula is RE is equal to 1 plus R divided by Q raised to Q minus 1. This Q is nothing. This Q is the number of times it is getting compounded. For example, when I say when I say quarterly, then Q is 4. When I say monthly, the Q is 12. You can write any alphabet. It can be M also, Q also, A also, B also, whatever. Okay, so this you can write it as divide by M raised to M. You can write like that. Okay, so when you write like this, you just write a sentence where M is equal to number of times interest is computed in a year. Okay, so let's use the same question. Okay, because effective rate of return we were finding. So see, I got 11.38%, right? Okay, let's try that only. Okay, suppose my rate of interest is 10%. So 1 plus 0.10, my interest is compounded quarterly, so divide by 4 raised to 4 minus 1. When you compute this, 1.10 divided by 4 plus 1, 1.10 divided by 4, sorry, just a second, 0.10 divided by 4, 0.10 divided by 4, okay, plus 1, it comes to 1.025. So 1.025 raised to 4 minus 1. When you compute this, okay, so into is equal to 3 times, 1, 2, 3, Okay, and then minus 1, minus 1, it comes 10.38%. Oh, I think I have 10.38%. I think I have done some mistake here while calculating. It should be 10.38%. Yeah, correct. Compound interest comes to 1038, not 1138. See, $10,000 into 1.1038. It is like that. Okay, 10,000 into 1.1038. Okay, yeah, minus 10,000. It comes to 1038. Okay, I wrote 1138, but it is 1038. See, it comes 1038. Oops, 1038. 38. Okay, 1038 upon 10,000 into 100, it comes to 10.38%. So when rate of interest is 10%, compounded quarterly, effective rate of interest will be 10.38. Okay, so the answer, see, we can make mistakes here. Okay, here the chances of mistakes are very less when you use this formula and solve. Okay, so yeah, this is the way to solve effective rate of interest. Okay, so let's see the next problem. Find the effective rate of interest if 6,000 is invested. How much is invested on all? We don't need it. Okay, 6% per annum compound interest calculated monthly. Okay, so you only need R, and you need how many times it is calculated in a year. That's it. Okay, so RE is equal to 1 plus R upon M or upon Q, whatever, raised to M minus 1, where M is number of times interest is compounded in a year. Okay, so RE is equal to one plus R. Effective rate of interest is 6%. That means 0.06. 0.06 divided by M. M means 12, because in a year it is compounded 12 times. Correct? So divide by 12 raised to 12 minus 1. Let's calculate this. 0.06 divided by 12 is 0.005. Okay, plus 1, that is 1.005. 1.005 raised to 12 minus 1. 1.005 raised to 12. Okay, so 1.005 raised to 12. So into and is equal to how many times? Raised to 12 means 11 times. Okay, or you can start your counting from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so raised to 12 means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 1.0617. Okay, so you can write 1.0617. 1.0617 minus 1. So this is 0.0617. So 6.17 is the effective rate of interest. Okay. Okay. Now let's see the next problem. Oh, I've directly jumped to problem number 34. Okay, anyway, I'll give you one question. Okay. Find the effective rate of interest when a sum is lent at 18% per annum, compounded quarterly. Okay, because question number 33 I have not written. Okay, I'll give you as homework. Okay, so find the effective rate of interest. You are supposed to find RE. Okay, find the effective rate of interest when a sum lent at 18%. Okay, so R is 18% per annum. R is 18% per annum and it is compounded quarterly. So that means my M is 4. Okay, so yeah, M is 4. Okay, solve this. This is a homework. Okay, so I'll just give away the answer. Answer should be 19.25%. If you get this answer, that means what you have done is correct. Okay, let's come to question number 34. Okay, so if 50,000 amounts to 75,550 in 3 years, interest being compounded quarterly, find nominal rate and effective rate of interest. It should be effective rate of interest. Okay, let's find out. You are supposed to find R and you are supposed to find RE also. Okay, so let's find R first. Okay, before finding R, let us see what all things are given. Okay, here P is equal to 50,000, A is equal to 75,550, N is 3 years, interest being compounded quarterly, so M is 4. Okay, so you are supposed to find R. You are supposed to find R and you are supposed to find RE also. Okay, so let's find R first. Okay, so R is equal to anti-log log A minus log P upon N minus 1. Okay, so this is the formula. Okay, but because it is compounded quarterly, so R divided by 4 you will do and N multiplied by 4 you will do. So this is the formula. Okay, because it is compounded quarterly, because interest is compounded quarterly, so R divided by 4, N multiplied by 4. Okay, so let's substitute anti-log log A is 75,550 minus log P, so log 50,000 divide by 4 into N. N is 3 years. 4 into 3 minus 1. Okay, let's find log 75,550 and log 50,000. Okay, so log 75,550 and log 50,000. Okay, so there are 5 digits. Okay, so 5 digits means 4 point something. Okay, so row 75, column 5, mean difference 5. Okay, let's see this. Row 75, column 5. Column 5, row 75. It is 8779. Okay, 8779. Mean difference 5. Mean difference 5 is 3. Okay, so plus 3. 7, 9, 8, 9, 10, 11, 12, 1, 2, 8, 7, 8, 2. Okay, so 4.8782. Okay, I am just checking again. Row 75, column 5. Column 5 is 8779 plus mean difference 8779 plus mean difference 5. Mean difference 5 means plus 3. So 79, 80, 81, 82. Yes. Okay, and log 50,000. So row 50, column 0. Row 50, column 0 is 6990. 6990. 6990. Okay, so yes, anti-log. Okay, so this is 4.8782. 4.8782 minus 4.6990. 4.6990. Okay, divide by 4 into 3, which is 12, minus 1. Okay, anti-log. Let's calculate 4.8782 minus 4.6990. Okay, divide by 12. 4.8782 minus 4.6990 is equal to 0.1792 divide by 12. It comes to 0.01493. Okay, so 0.01493. I will keep only 4 decimals. Okay, anyway in anti-log you need only 4 decimal only. Okay, minus 1. Okay, now let's find anti-log of anti-log of 0.0149. Okay, so row 0.01, column 4, mean difference 9. Okay, row 0.01, column 4. Okay, so let's go to anti-log table. Row 0.01, column 4 is 1033. Okay, so 1033, mean difference 9. Mean difference 9. Mean difference 9 is 2. So plus 2. So it comes to 1035. Okay, because before the decimal it is 0 digits. So 0 digits plus 1. So 0 plus 1 is 1. So after 1 digit you will put a decimal point. So 1.035. Okay, so this is 1.035 minus 1, so which is 0.035. Okay, so r divided by 4 is equal to 0.035. So r is equal to 0.035 into 4. 0.035 into 4, it comes to 0.14. Okay, which is 0.14 or 14%. So the answer is 14%. Okay, so r is 14%. Let us find effective rate of return. Okay, effective rate of return formula is RE is equal to 1 plus r raised to m, 1 plus r upon m raised to m minus 1. Okay, so 1 plus 14 upon 4, because interest is computed 4 times in a year, interest is computed quarterly. So 14 divided by 4 plus 1, 14% means 0.14. Okay, r means 0.14, 14% means 0.14. Okay, so 0.14 divided by 4, it comes to 0.035 plus 1, so 1.035. Okay, so 1.035 raised to 4 minus 1. Okay, 1.035 raised to 4. So 1.035 raised to 4 into is equal to 3 times. It comes to 1.1475. 1.1475. 1.1475 minus 1, so which is 0.1475 or 14.75%. Okay, divide this by 100, you will get in percentage. Okay, so 14.75%. So yeah, so rate of interest is 14%. Okay, rate of interest is 14%. Rate of interest is 14% and effective rate of interest is 14.75%. Effective rate of interest will be little higher than rate of interest always. Okay, let's see the next question. The difference between compound interest and simple interest on a certain sum of money for 3 years at 6% per annum is rupees 264. Find the sum. Okay, try to solve this sum. Okay, I'll be solving the sum in the next class. Okay, so that's it for the day, students. Have a great day. Thank you very much.